Hi, in this video, I'm going to be going through three examples of identifying missing side lengths for special right triangles. This first triangle that we're given, angle measures of 30 and 90 are identified. That means that the last angle, 60 degrees, is the only other possibility. We know this because all angles of a triangle total 180 degrees. So remembering that for a 30, 60, 90 degree triangle, the smallest side we'll call A is equal to some value. The second smallest side or middle side we'll call B is equal to that value of the smallest side times the square root of 3. And the longest side we'll call C is equal to 2 times the smallest side length. This is true for all 30, 60, 90 degree triangles. So we can identify U very quickly. The longest side is equal to 2 times the smallest side. So U is equal to 4. How do we know that 2 is the smallest side? Well, the smallest side is across from the 30-degree angle. So now all we have to do is find the middle side length. The middle side length is equal to the smallest side length, which in this case is 2. So we'll say the side length V is equal to 2 times the square root of 3. Now that's as simplified as possible. We can't break that down anymore. So our answer is 2 root 3. Now let's take a look at a 45, 45, 90 triangle. The relationship between the side lengths of a 45, 45, 90 is slightly different. We know this is a 45, 45, 90 because that's the only other option for this side length. We also know that it's the only other option for this angle measure. We know that these two side lengths are also the same because those angles are the same. That's just based on the isosceles triangle. So this relationship that a 45, 45, 90 triangle has is that the longest side, we'll call it C, is equal to one of the smaller sides times the square root of 2. It doesn't matter which one's the smallest side because it's a isosceles triangle, and so both of those sides are the same. It's kind of nice for this question because once we identify one, we'll also have the other. So let's set up our equation. The longest side, in this case 6, is equal to some value of x times the square root of 2. Well, how do we identify what value of x that is? It looks like we could divide both sides by the square root of 2, but that could get a little tricky. So what I'm going to do is square both sides. I want to get rid of radicals. So I square everything on both sides. And now this gives me a value of 36 is equal to, don't forget to multiply each of these by that exponent. So x squared times the square root of 2 squared, which is just 2. So now we have x squared times 2 is equal to 36. This is so much easier to divide by 2 rather than the square root of 2. So 36 divided by 2 gives us a value of 18. 18 is equal to x squared. Now we take the square root of both sides, and we're left with x is equal to the square root of 18. And that would be our answer if we were okay leaving things in a non-simplified form, which we are not. 18 can be factored into 2 times 9, which is then 3 times 3. So our side length x is equal to 3 root 2, and likewise the side length y is equal to 3 root 2. All right, lastly, and I'm going to zoom in a little bit on here so we can focus on it, we're trying to identify the longest side and one of the other shorter sides. In this case, it's another 45, 45, 90. So we already have our b value. We know that the other side is the same as the given side. So b is equal to 2 root 2. Now the only thing we have to do is find sine length a. We can do that using the Pythagorean theorem just fine. 2 root 2 plus 2 root 2, both squared, should be equal to our longest side squared. In this case, we'll call it c squared, even though it's labeled a, just because we're used to calling it c squared. And no, we won't. We'll call it a squared because our diagram says a. Now, let's go through this process and we'll see that we'll identify the correct value of a, but we can also use our understanding that a is actually equal to the other sides, 2 root 2 times root 2. And I hope you can already identify what our side length a is going to be, but I'll use the regular Pythagorean theorem so we can confirm it. 2 times root 2 squared is equal to 4 times 2. And likewise, we'll have the same thing here, 4 times 2. And this is all equal to a squared. Well, 4 times 2 is 8, plus 4 times 2 is 8. Well, 16 equals a squared. Square root of both sides, a equals 4. Now you should have already seen that here because square root of 2 times square root of 2, that's just 2. 2 times 2, 4. You can see one way is a lot faster. If we know the relationships of the side lengths for a 45, 45, 90, we don't have to go through the entire Pythagorean theorem. We can identify our missing side length very quickly. I hope this helps, and if you have any questions, please let me know.